Welcome to The Explainer, brought to you by Forge College. I am absolutely thrilled you're here. Today, we're diving into comparative analysis and final submission. We're gathering up all our EVM to SVM transition tools and finalizing the master blueprint of our Capstone project. If you've been following our track from EVM to SVM, and specifically this Advanced ERC Patterns on Solana course, you know we've been deep in the trenches of code. Now it's time to zoom out, synthesize everything we've built, and prep a final deliverable that proves, beyond a shadow of a doubt, that your code is ready for production.
Think about what you've accomplished so far. You've been incredibly busy building these sub-assemblies step by step. From engineering the Vault program with tokenized shares, to constructing the gasless transaction flow, all the way to our previous lesson on building a session key abstraction. You've got 3 beautiful, isolated prototypes. And now, well, it's time to wire them all together into one unified, perfectly reproducible engine.
So, here's our engineering assembly manual for today. First up, the Capstone goal. Second, gathering implementations. Third, comparative analysis metrics. Fourth, safely managing AI vibe coding. And finally, we'll wrap up with the reproducibility checklist. Let's get right into it.
Section 1. The Capstone goal. This is all about building the unified engine.
All right, so here's the deal. You are no longer just writing isolated scripts on your laptop. You're producing a highly curated professional package. To pass this capstone, you've got to deliver a single consolidated monorepo. Inside that repo, we need to see your 3 working implementations: the Vault, the gasless flow, and the session key abstraction. But listen, code alone just isn't enough. You need locally runnable, automated tests for all of them. And backing the whole thing up, you need a comparative analysis document explaining your design trade-offs, plus a final submission checklist. It's basically like handing over the keys to a high-performance vehicle, but making sure you also include the owner's manual and the safety inspection report, you know?
Moving right along to Section 2, Gathering Implementations, or as I like to call it, the blueprint layout. Think of your repository structure like a flawless architectural blueprint. Step 1 is pretty straightforward. Create that top-level monorepo with 3 neat little directories. Step 2 is where the magic actually happens. You need to consolidate your tests with a setup script. Gone are the days of manual key prompts. We're replacing all of that with slick script-driven environments. Step 3 requires you to explicitly link code excerpts directly to your comparative analysis document. Reviewers shouldn't have to go on a scavenger hunt for the logic you're talking about. And Step 4, instrument reproducibility checks via CI, or continuous integration. We're writing a master test script so evaluators don't have to guess how to spin up a local validator. It should just work right out of the box. Section 3. Comparative Analysis Metrics. Let's talk about exactly how we're measuring the machine. When you document your objective criteria, you've got to be incredibly specific. Take complexity, for example. You can't just write, it's pretty simple. No way. You need to cite lines of core logic, the number of account types, and specific signer checks. For gas and fees impact, we want to see the simulated lampports per flow running directly on your local validator. Reproducibility literally means tests pass on a completely fresh checkout, absolutely 0 manual tweaks allowed. For the security surface, you've got to count those privilege keys and document your revocation pathways. And finally, developer ergonomics. How clean are your APIs? What do your test scaffolding examples actually look like? You must synthesize hard evidence linked directly to your code. Opinions are cool, but in this capstone, evidence is king.
Section 4. AI vibe coding safely. Or, how to manage the eager intern.
So, vibe coding is a relatively new term, but man is it relevant right now. It refers to using AI-assisted drafting to seriously speed up your workflow. You can use it to draft those comparative sections, spin up test helper templates, and just absolutely crush repetitive documentation tasks. Honestly, I like to think of vibe coding as having an incredibly fast, highly enthusiastic, but maybe slightly hallucinating intern sitting right next to you. They can type 1,000,000 words a minute and set up boilerplate code in seconds. But guess what? You are still the senior engineer who has to sign off on their work.
Which brings us to your golden rule for the rest of your Web3 career. Audit auto-generated content and do not accept it blindly. You absolutely must review the AI's work. And to prove you actually did this for the capstone, you are required to leave verification notes in a specific drafts folder. This proves to the evaluators that you didn't just let your eager intern compile the final engine while you were out getting a coffee. You treated the AI's output as a scaffold, and you, the human architect, verified its structural integrity. Finally, Section 5, the reproducibility checklist. It's time for the final factory floor inspection. Let's define exactly what we mean here.
A reproducibility checklist is a documented set of script-driven setups and deterministic fixtures. Now, why is this the ultimate engineering flex? Because it completely destroys that classic, dreaded excuse, well, it works on my machine. By using a single, elegant orchestrator script that deploys the local validator, funds dev accounts, and tests everything automatically, you are guaranteeing it works on every machine. Zero manual intervention. It's a beautiful thing.
To make this happen, you'll create a single submission markdown file. This acts as your final punch list on your engineer's clipboard. It gives the evaluator everything they need in one quick glance. You'll include the repository URL and the exact commit hash so they're looking at the right version of history. You'll include condensed test run logs in a simple text file showing exactly what passed, provide the exact copy-pastable commands to reproduce your environment locally, add a direct link to your comparative analysis doc, and of course, those verification notes we just talked about regarding your AI intern.
Just consider the manual setup nightmare for a second. An evaluator trying to guess your build commands, fumbling with manual key prompts, and tripping over completely undocumented dependencies. It is incredibly frustrating, and honestly, it loses you points. Now compare that to automated bliss. They clone your repo, type run all tests, sit back, watch the local validator spin up, and see a gorgeous report of 0 failures. Passing these checkpoints guarantees you deliver that automated bliss.
Okay, let's quickly recap the 3 main pillars you need to take away from this explainer today. First, synthesize evidence, not opinion. Anchor your claims about gas cost and complexity directly to your chest outputs and code snippets. Second, automate your reproducibility. Script-driven setups and deterministic fixtures are absolutely non-negotiable. And third, always double-check your AI intern's homework. Audit those generated artifacts and document your verification process.
And that leaves us with a final, slightly provocative thought. You've built these incredible, modular, on-chain Solana pieces, but how are they going to interact with the off-chain world? In our next module, we'll dive into SVM client architecture, exploring client RPC patterns and wallet adapters. Keep that in the back of your mind as you finalize this capstone. Thank you so much for joining me on this explainer, brought to you by Forge College. Be sure to visit Forge College to continue your Web3 journey and dive deeper into advanced Solana engineering with us. Happy coding, and I'll catch you in the next one.